Today we have easy problem. We're given a list of numbers and we ask to find how many steps we should make to turn this array into sorted. So the problem is simple and it can be solved with simulation. In one step we take the smallest sum of pair and we merge it and we put back the value. So the simulation is kind of simple and trivial. You have to iterate possibly infinity times, but we can be sure that it will be at most the size of the array, and then we have to find the minimum sum, like it is in description by the rules, the minimum. Then we have to create the new array, and the entire operation of creating this new array is of n. So the final algorithm is n squared in time complexity and of n in space complexity. Now let's look at my solution. So I converted this to list, and then I just compare. It's just short version of checking, but we can just count how many unordered values we have. Okay, this is not very effective, but it is short, and we only have like 50 values, so it is acceptable. Now I find this minimum index, and after that I created the new list, and this is the entire solution. Now let's look at some other pretty interesting solutions. So this solution is the same idea, but in a recursion way. So instead of using while loop, we can just do the same, but use recursion. So all the steps are the same. Now the Rust implementation, same idea. I don't sort in Rust. I just use the linear check, and this is also find the minimum value of the sum. And this is kind of different way to handle the removal. So instead of creating the new array in Rust, I can replace and remove just one item. So it is also a workable solution. It also n square implementation, because to remove this you have to move the entire suffix of, or the tail of the array. Now the hard part of this question, and it has the number 2 version of this question, when we actually have a bigger array, and it can be solved with different ideas. So if we have like this array, and to solve it the hard way, we have to maintain the original positions, like to the left and to the right indexes. So basically can convert this to linked list. Then we have to put all the adjacent sums into some sort of collection. Put all pairs into hash, into maybe priority queue. To have the sorted order. And when you do the poll, we can have stalled stalled positions on stalled sums. So we have to ignore stalls, I would call it. And then the converted linked list implementation is like left position of I is also position and right position of I is also position. So it is like union find or path compression. So it's like path links. And when we do finding this minimum value by polling, we have sum and index I, and then we have to disconnect linked list. So we taking left, we taking right, and we taking removing this position. We have to agree that I index now would have the value of sum, and the right position we removing. So instead of right, we have right. This is kind of removal of linked list. The left can stay the same, and before doing disconnect, we have like before situation and after situation. And in before situation, we have some number of unordered items. So this can be one, and the second one, all unordered parts. So we have like 1, 2, 3, 4 unordered parts. And when we do this kind of trick, the number should be like these parts should be removed from the counter, or maybe we should increase the count of unordered parts, and then we have to count back like this by comparing them again. So I looked at these solutions. So I think that tomorrow's solution would be like that. And this solution is kind of hard. I don't know, and I'm sure that I can write it myself. So I just copy pasted it and done some tweaks. But I will hope that tomorrow my mind prepared to this kind of problem. So that's it for today.